Advancements in genomics and proteomics over the past 2 decades have propelled assay development to ever-increasing levels of sensitivity and sophistication. However, one challenge has remained: the continuous measurement of morphological, chemical, and physiological change in live cell populations over time. This window of opportunity in the research field is attractive because it is much less expensive than live animal and organ models, yet can deliver significantly better information than studies involving dead or fixed cells. Though techniques exist to isolate, study, and measure individual cells, they rely on endpoint measurements. Within a typical experiment, cells are introduced onto a growth medium and are then subjected to various treatments, stimuli, agonists, or promoters. Treatment or stimuli can range from the binding of a ligand to a receptor, the infection of a cell with a virus, the transfection of a cell with foreign DNA or RNA, a change in the environmental conditions, exposure to a therapeutic compound, or a physical stress. These studies can give gross estimates of change over time using successive invasive or destructive measurements. However, they still do not address what is happening within these living cells on a real-time basis. In addition, these studies typically measure only one molecular component within the complex structure of the cells. They are not providing enough information. In sharp contrast, the xCELLigence system can continuously measure changes within the living cell through electrical impedance. The heart of this technology lies in the uniquely designed microelectrodes that cover 80% of the surface area at the bottom of each well. As a small voltage is applied across these electrodes, the impedance can be measured. When the wells contain only media, a baseline impedance can be read, as determined by the ionic conditions of the media. Cells are added to the plate. They settle onto the surface of the microelectrodes and begin to attach and grow. As cells proliferate and the population increases over time, the measured impedance will rise. Changes in their adherence, viability, or morphology will also result in a change to the impedance measurement. The xCELLigence system can monitor distinct cellular status, such as cell adhesion and spreading, lag phase, growth phase, and confluence. Subtle subcellular changes can also be detected via impedance changes, which are recorded for each population of cells adhering to the plate, providing unprecedented comparative data from well to well within one experiment. Impedance of the microelectrodes is constantly monitored using the Real-Time Cellular Analysis, or RTCA analyzer, and is converted to cell index reading using computer algorithms. The RTCA analyzer allows for not only quality control of the cells, but also selection of optimum time points for treating the cells and for quantifying the treatment effects. In xCELLigence, cells are in their natural physiological states and not labeled with any foreign molecules. The label-free nature of the xCELLigence system allows the cells being harvested for additional assays at the end of an experiment. The real-time impedance-based readout from the xCELLigence system provides a quantitative way of assessing cellular behavior that is not possible by visual microscopic examination, and can also aid in assessing and comparing the quality of the cells in different wells of the same plate, as well as between plates in different experiments. The xCELLigence system is to biology what the film camera was to still photography, a revolutionary method of seeing and recording change in real time. xCELLigence. Discover what you've been missing.